Hey everyone, I'm back from Australia. I'm wearing my Star Stuff 2 shirt. In case you didn't know, I just did 3 weeks in Australia with my wife. I was one of the speakers at the Star Stuff 2 convention in Byron Bay, Australia. I gave one talk sort of just after everyone had their dinner. And then I did one of my, patented question shows the next morning and answered questions from people. I'm not sure if the video is available anywhere on the internet. Maybe you just had to be there. But thanks to Dylan O'Donnell and the rest of the Star Stuff crew. I had an amazing time. You were the best hosts. Everyone who I got a chance to meet there at Star Stuff, I'm so glad we got to meet in person. If you're going to be in Australia, you should check out Star Stuff and see if you can join their Star Stuff 3. All right, let's get on with this week's questions. Jonathan Adami. That day when someone will prove that dark matter is BS and will watch videos like this thinking, oh boy, we were cute in the past. I see the same thing come up again and again, which is like this sort of like, oh, you idiots who think that dark matter is a thing, you're such dummies, right? And of course, keep in mind that there are astronomers who have spent their entire careers, right? They've gotten their bachelor's degree in science, their master's degree in science, they've gotten their PhD, they've dedicated all of that time, whatever that is, 13 years, to understanding the state of astronomy as it currently stands. And then they've specialized in one of these fields, dark matter. You would think that if you put all this time, it would have occurred to them at some point to go like, oh, are we dummies? Right? So, and I think it's really important to see that dark matter is not this thing that astronomers have invented. They're like, oh, let's just come up with something and then that'll keep the pork barrels running, or however that works. It's that there is a mystery. And there's this great analogy, I think I've used this before, Dr. Pamela Gay, my co-host on Astronomy Cast, brought this up, right? This idea that you're driving in your car and your car is making this funny knocking sound and you know what's happening, but you don't know what's causing it. You know the sound is there, and you go to the mechanic and the mechanic can't figure out what it is, and the mechanic says, well, drive some more and figure it out. So you go out and you drive some more, and then you realize that it only happens when you're going up a hill and when you're turning to the left, and you bring it back to the mechanic goes, okay, now I've got more information, I can figure out what's going on. And that's the state of dark matter. They know it's there, they're narrowing down what it could be, what it couldn't be, and they're getting to the point of it. But it's a puzzle, it's a mystery. And so all they've got is these little hints that this thing is there, and they're trying to figure out the rest and trying all these experiments and trying all of these particle collisions to try and figure out what could be causing it. And right now they're ruling out the things that it isn't. And so actually I'm going to work on an episode right now, probably the next episode, is like, what is the state of dark matter today, and what are all the experiments that people are working on to try and search for it, to try and figure out which one of these possible mysteries that it is, or something else. And dark energy is even weirder, right? Like, all they know is that the universe, the expansion of the universe is accelerating. And so they can measure that this expansion is happening, this acceleration is happening, but they have no idea what's causing it. It is a true, pure mystery. And you are in the middle of the mystery. Think about all these other mysteries in the past. Quasars, supernovae, black holes, all kinds of things that they just like, here's a weird thing, didn't know what it was, and then over the years, months, decades, centuries, astronomers tried to figure out what was going on. And you happen to be in the middle of this mystery. And I think until you've taken the time to get yourself up to speed with the state of how the mystery came about and where people are in uncovering it, you can't really judge whether it's a real thing or not. But I'm going to do a video all about this, so thanks for inspiring that. Almir Selkovic. Is the event horizon from a spinning black hole round, or does it bulk out like planets or stars? Right, so you're talking about how planets, stars, as they spin more rapidly, they flatten out and they become an oblate spheroid. And the answer is yes. Black hole event horizons will flatten out the faster that the black hole is spinning. And one of the really cool things about this is that as the black hole spins faster and faster and faster, this event horizon will flatten out, but it can never spin so fast that the actual singularity will be revealed. This is called a naked singularity. And the reason is because Einstein's general theory of relativity defines that you can't go faster than the speed of light. And one of the things that you can't do is a black hole can't spin as fast as the speed of light. So there is this limit that a black hole can spin, predicted by relativity, and that defines how much this event horizon will flatten out. But it's an amazing thought. And of course, when the Event Horizon Telescope comes online, or when that first picture is released, people promise me spring 2019, hopefully, as we see that image, we may be able to detect that flattening out as the black hole is rotating, or maybe not. But it's a really interesting idea to imagine. Headless Horseman MC. Hello Fraser, if you were a scientist, what would you want to be? So if you know my education history, I went to the University of British Columbia for engineering, and I went for 1 year and washed out. It was not for me. I thought that I was going to be designing rockets and aerospace engineering stuff, and I ended up calculating the loads on various construction supports and things like that. Now I'm sure I could have specialized later on, but I clearly just don't have the brain for being an engineer. So I went off to go into computer science, and that's what my education background is in computer science. And I love computer science. And honestly, if I didn't stumble into astronomy journalism, I would probably be running tech companies again, in computer science, probably in AI. I find that really fascinating. So that's probably where I would be if I wasn't a astronomy journalist. But you kind of can't control when you find your perfect career. So I love what I do. Craig O'Brien, question time. Forget time, money, and air. Could you build a ladder into space and climb up? You forgot one thing, which is the material science required to make such a ladder. But in fact, this line of thinking is where the whole idea of space elevators came from. That originally people thought, well, if you built a ladder as tall as the height of geostationary satellites, what is it, 44,000 kilometers? I forget the exact number. If you built a ladder that high, you could climb up that ladder all the way. And when you got to the top of it, you would no longer need to be going sideways in orbit to remain at the distance from the Earth. You would essentially be in that geostationary orbit in the same way that there are these satellites that appear to be perfectly hovering right over the Earth. Now, the reality, of course, is they take 1 day to orbit around the Earth, and the Earth turns once during that day. So if you could get up to that height and farther, you could eventually reach a point that you could just sort of push off, and you could eventually fly off into deep space. And so that idea of building a tower that would allow you to climb out of the Earth's gravity well and escape into the solar system has been adapted to think, well, instead of that, what if you just had a tether that came down and was perfectly balanced, where part of it is just getting to the surface of the Earth, and part of it is getting beyond the Earth, and there is this point where you don't need any more orbital energy to get away from the Earth. You just have to be able to climb up out of that gravity well. So it's a great idea. The only problem is, of course, there is no structure that you could build that would be that high. However, you could do that on other worlds. Maybe you could do that on an asteroid, or maybe you could do that on a moon of another world. So there's some pretty cool ideas on how you could actually escape not using rockets. Funky Loiso. Does stuff in galaxies, solar and planetary systems always rotate in the same direction around the center? Why? What about the asteroids, rogue planets, and stars? The answer to that is mostly. Most of the objects in the solar system are orbiting around the sun in the same direction. All of the planets, most of the moons are orbiting around their planets in the same direction, mostly. Most of the stars in the Milky Way are orbiting around the center of the Milky Way in the same direction, mostly. And then you get these weird ones that don't. In fact, there was this great discovery just at Jupiter. It discovered like 12 new moons around Jupiter, and Jupiter has these really cool moons. Some of them go around in the same direction as the rest of the solar system, and then there's a whole bunch in a prograde direction a little bit farther out. But they found one new moon in that bunch that goes the same direction in the prograde direction, or in the regular direction. Anyway, the point is that you have to have some weird circumstance. Triton, which goes around Neptune, is going backwards from the rest of the objects in the solar system. And so you have to imagine some special event caused this. Maybe Neptune captured Triton as a Kuiper Belt object. And same thing if you found a star going in the opposite direction somewhere in the Milky Way. It had to have gotten captured. And the second part of your question was why? Why does this happen? And of course, this shows that they were all tied to this same event. Back in the beginning of the solar system, you had this one big cloud, and the whole cloud collapsed, and it all set into rotation in the same direction. And then as it did, flattened out, you got the star at the middle, and all the planets formed within the planetary disk that surrounded the star. So it shows that all of that happened in one big event. X light bringer X. Who else is beginning to doubt the existence of JWT? Oh, I know, it's so frustrating that James Webb is taking longer than we had all hoped, but NASA just did a pretty in-depth, independent study of the state of James Webb, thanks to sort of where the Northrop Grumman is at with the construction. All of NASA's components are complete. Northrop Grumman is having some challenges, which are not surprising. If you've ever worked on a software project or a hardware project, this happens all the time. And NASA are some of the best project managers that are out there. And so they came in and did an independent study. And I feel pretty confident now that the new date that they've chosen for when this spacecraft is going to launch is pretty accurate. Now, it could drift more, and there's a great XKCD cartoon that says, from when it was originally predicted, and each year they sort of keep pushing the date out, and XKCD guesses 2026. It's too big to fail. It's gonna launch. Now let's hope it makes it to space. Ranu Loik. I'd like to know, how do black holes influence space travel? Obviously, if you flew right into a black hole, you would be influenced by your space travel. but beyond that, right, you need to stay outside of the Roche limit of the black hole, and that depends on what your spaceship is made of. But within several astronomical units of the black hole, depending on the mass of the black hole, a supermassive black hole can have an event horizon that's the size of the solar system, while a stellar mass black hole can have an event horizon that's actually quite small, just a few kilometers across. So as long as you stay outside of of the Roche limit of your black hole, then your spacecraft is going to be able to survive. It'll be very uncomfortable. Now, the cool thing about black holes, though, is you could use them for planetary slingshots, right? I guess black hole slingshots. So you could harness the orbital energy of a black hole to kick you faster into some other destination that you want to do around the Milky Way. And if you watched, oh man, what was that movie? Passengers? Is that the one where the guy is on this spacecraft? No, you remember? Anyway, there was this movie that came out, I think it was Passengers, where they had this big spaceship and they were traveling and everyone was asleep, and guy woke up this other woman to keep him company, dooming her to a lifetime on a spaceship. But in that, they were using stars for gravitational assist, which I think is a really cool idea. So you could use black holes as well. So as long as you stay far enough away from them, you can use them to speed up your travel, depending on where you're looking to go in the Milky Way. Josh Greening. I wish I would have known the WSH was a channel here on YouTube. I always thought it was something from Universe Today webpage or weekly newsletter, or even something for your Patreon, LMAO. Yeah, you might think that by watching these question shows and maybe the occasional guide to space video, you are fully caught up on all of the things that I do, but you are sorely mistaken. I do everything all the time. So just to run this down for you, right? I am the publisher of Universe Today, which is a space and astronomy news website. I run this weekly email newsletter, which you should be subscribing to. Go to universetoday.com/newsletter. I am the co-host of the Weekly Space Hangout, which is this weekly news rundown with my co-hosts, Dr. Morgan Renberg, Dr. Kimberly Cartier, and Dr. Paul Matt Sutter. We do that every Wednesday. Now, we're on hiatus right now, but we'll be back in the fall. I'm the co-host of the Astronomy Cast podcast, which I've been doing for the last 10 years with my co-host, Dr. Pamela Gay. We are going to be celebrating our 500th episode in St. Louis in September. So those are sort of the vast majority of the things that I do. I show up on Skylius Cares, who is one of the top science streamers on Twitch every week on Thursdays. I also am going to be returning. I used to run the Virtual Star Party, which was this really cool live stargazing event that we used to do every week. I promise, it's coming back. So the best way to be in touch with all of the things that I'm working on is to actually sign up for the newsletter, universetoday.com/newsletter, and then I will sort of list all the things that are happening this week. And we just wrote a book, which is going to be coming out October 23rd, the Universe Today's Complete Guide to Viewing the Cosmos, with Dr. Dave Dickinson and a whole bunch of astrophotographers. I coordinate all of the cool photos on our Instagram page. We have a different amateur photographer take over every day. I post a bunch of news on Twitter. Anyway, I do a lot of things. So check them out. Roigdal. What an ass, man. So you don't have the balls to say that Space Force is just stupid? You were a hero to me. Not anymore. I'm sorry. That was a Canadian sorry, of course. I think what I said in that video, and I've responded again, is that the idea of a Space Force is as stupid or as good as the size of the thing that needs protecting. And in the case right now, there are no humans in space, so there's no need for any kind of military space force flying around on their space battleship to protect the cosmos from aliens and space terror, space pirates. But eventually you can imagine some far future when there are colonies on Mars, there are mining operations, and people are being bad in space. And you can imagine, like, it'll start with probably a Coast Guard and then move to something larger as the various nations are looking to take over more and more of the solar system. My hope is it'll never happen, and it will always be a ridiculous idea. But I also have noticed, and maybe you've noticed this too, that wherever human beings go, we tend to take our militaries with us. It's premature, is my opinion right now. Space is already militarized literally as much as makes sense, and no more. And also is prevented by, they're not allowed to put nuclear weapons in space thanks to the Outer Space Treaty. If the Outer Space Treaty breaks, if there's more populations out in space, there's going to be military in space. So it is, like I said, it's premature, and yet realistically, you can imagine some far future when it happens. Knee down, Brown. Intergalactic gas? Isn't there also interstellar gas? What implications do you think that interstellar gas might have for manned or unmanned interstellar travel? Yes, one of the hazards of spaceflight as you're flying through space is you're going to be bumping against the protons and particles of dust and the stuff that's in the interstellar spaces. And what is just a chunk of sand bumping off your windscreen when you're going 20% the speed of light is going to be hitting you with the force of a nuclear weapon, right? It's going to be bad. Not to mention, as you go faster and faster, you're going to get sort of more radiation as the radiation that's coming towards you, as the particles you're bumping into. It's going to be a pretty dangerous environment. That said, even though some of these particles of gas could be millions of degrees centigrade, they're not going to transfer to your spaceship. Like, imagine you stopped your spaceship in one of these giant gas clouds where all the particles were several million degrees centigrade. It's not going to overheat your spacecraft because the density of these particles is very low. Very few of them are actually going to be bouncing against your spaceship and transferring their heat. And I want to give you sort of an example so you can sort of imagine this, right? If you put your hand in boiling water, do not do this. Do not put your hand in boiling water. You will be burned. Now, if you put your hand over steam, again, do not do this, right? You can get a steam burn from that steam. But I'm sure you've experienced where your hand is like really far away, or steam is blowing off something, and even though the individual particles are still very, very high, you're not getting burnt. And that's because the density of those particles is very low. Not very much of that energy is getting transferred to you. So if you're out in space, you're not going to overheat from being in these gas clouds of millions of degrees, but if you try to move through them very quickly, you could have some problems. Again, don't put your hand in boiling water. Don't put your hand in front of steam. Did I say that enough times? It's super clear. Don't look at the sun without proper protective eyewear. And wear sunblock. Roland Robledo. G'day, Fraser. Is it possible to attach a braking system to those light sails, such as nanothrusters programmed to operate in some time frame when the spacecraft is approaching near its destination? Thank you. Not nanothrusters, right? When you think about what it took to get you moving at 20% or 10% the speed of light, it took a gigantic laser system that blasted, put a tremendous amount of energy into one of these little nanosails, and away it goes to another world. You're not going to then have some thruster that would then slow down your spacecraft so that you could go into orbit around this other star. It just would require more fuel and energy than you could possibly have. But there are some pretty cool ideas to be able to slow yourself down. One is using the magnetic field or the light pressure that's coming from the star, the target star, to slow you down as you come. So maybe you unfurl a larger sail, and that slows you down as you get close to that star, and maybe there's a way to do the math. And there's another idea that I really like, which is that with your nanoprobes that you send, you also send maybe a laser system, and that laser system was a lot more expensive to send, and it maybe detaches from the probe, turns around, and shoots at the little probes as they're coming towards it and slows them down. And that might be another way to be able to do it. You can get a little ahead of them, slow them down, act like a parachute, and then it will crash into the star, but the probes might be slowed down a little bit. So this is definitely a concern. The first probes that go will probably have no way to slow them down. They're just gonna go past, take some pictures, send some images home, and that's all we can expect. But hopefully down the road, especially when more infrastructure is set up on these other stars, you could have these big laser systems that exist on other stars, and they catch the spacecraft as they arrive, slowing them down with a laser in the reverse way that they were accelerated in the first place. And then we would have a true Milky Way spanning civilization, which I love as an idea. Seth Cooper: if orbital hops become the new way to travel long distances, will there need to be specific airports built to handle that kind of traffic, or will normal international airports work without any upgrades needed? It depends on the method that you're going to be using to do these short hops. When you look at something like, say, Spaceship Two, it is an airplane. And so all you really need is a really nice long runway, and then you got the Spaceship Two underneath, and the thing takes off and flies up and releases the Spaceship Two, and it goes up to do its 100-kilometer flight and then comes back down, and then the White Knight 2 flies back and lands on the runway, while, say, the BFR, right, is going to be this gigantic rocket that's going to produce a tremendous amount of energy. If one has an accident, it could take out a good chunk of a city. So you want them far away, so you would need to build a new facility. But something like the New Shepard that's coming out of Blue Origin, that's going to be a fairly small operation, but it's going to be launching from its own special launch pad. So each one is going to have a different way that it's going to operate, and some will actually be able to work from regular facilities. There is this new facility in Mojave, the Mojave Spaceport, and it was designed specifically for spacecraft like the Virgin Galactic to be able to take off and take people to space and land again. And so you can imagine in time there will be more and more spaceports and places that are both airports and spaceports. It's a pretty cool idea. All right, well, that's it. Those are all the questions this week. Thanks, everyone. I'm glad to get back in Canada. We're catching up all the content, so I think that's all it's going to be this week. But we will see you next week with a bunch of new episodes, question shows, live shows, streaming, all the things that I do. All right, we'll see you next week.